take a look at the review number 3. Let's do the odds. Now, the question says, to solve each inequality, graph its solution, and then use interval notation to show the answer. So there's really 3 parts to each one of these problems. But as soon as you get the graph, everything will kind of flow the way you want it. Okay, so let's take a look at our first problem. So if we look at that inequality, we have 2 ends on the same side. That, just like an equation, simplifies. So you get negative 24 is greater than negative 12n. Now, the main difference between an equation and an inequality is if you multiply or divide by a negative, you have to flip the sign. So as soon as I divide by a negative, I'm going to mark that sign somehow. If I was doing it on a sheet of paper, I'd just circle it, so that I remember the next time that I write it, I've got to flip it over. So a negative 24 divided by a negative 12 is 2. Now, unlike an equation where it doesn't really matter who gives a darn how you leave it. If this was an equation, 2 equals n, n equals 2, who cares? But for an inequality, we do want that n to come first. So I would do a little rewrite to that, and I would just turn it, and I would make that n is greater than 2. Because if you don't turn it, you're more likely to use a less than, and that's not right. The n is greater than the 2. I think the alligator's eating the n. It's a silly way, but okay. It eats the bigger one. The alligator eats the greater one. Okay. Now that we have the solution, because remember there are 3 parts. Solve the inequality, we've just done that. Now put it on the graph paper.
So you flip it and then flip it again?
Yes, yes. So the negative flips it at first, and then the act of turning it will flip it as well. So it's actually a turn for this one. It's kind of a strange thing that happens. And it's just because the n was on the wrong side, okay? So remember, it's an open circle if there's no equal to. Greater than 2 means we shade to the right. Now, if you're unsure if you flipped it right, let's think about if we plugged in 4 into the original version, because the original version should check itself for you. If you put in 4, you get negative 24 is greater than, let's say that you did the math, is greater than negative 48. And all you just have to ask yourself is that a true statement? Because if I colored in 4, that means that 4 is in the solution set. If I plug in 4, I get negative 24 is greater than negative 48. Is that true? Yes, it's true. So I did color in the correct direction. Okay, that being said, the last step is to actually write it in interval notation. So, okay, remember what you're doing. Step 1, you're doing the solving. Step 2, you're graphing. Step 3, we want an interval notation. Write your variable, put equals, and then we're going to write the interval. So just think it follows the number line from least to greatest. The least is almost 2. The greatest is infinity. Now, we put a parenthesis on the 2 because there's no equality there. We put a parenthesis on in infinity because you can't really land at infinity. So it's going to go from 2 to infinity. It follows a number line. Interval notation should always be in number line order. That's why having the graph as a visual will help you do that. Everybody good with number 1? Okay, let's keep going, number 2. So let's solve it. Now we've got, I'm sorry, we're going to do number 3. Okay, so we're going to take this 4 and let's distribute it. Okay, so we get 4v minus 12 plus 8v is less than or equal to negative 72. So all I've done is distributed that 4 so that I can simplify that left side as much as possible. Now we have like terms of the v's, so that's a total of 12 v's minus 12. Okay, and then, you know, now it just becomes like an equation, but watch, if you multiply or divide by a negative, you're going to turn that symbol. So let's add 12 to both sides so that we get 12v is less than or equal to negative 60. divide by a positive, which is okay, it doesn't turn the symbol's gonna stay, we're gonna get that v is less than or equal to negative 5. Now, the fact that negative 5 is showing on our graph means that, yeah, hey, that's a good sign we did it right. Are we gonna have an open or a closed circle at negative 5? We're gonna have a closed one, right? So at negative 5, we're gonna put our circle. The symbol looks like the ending we see there. We're going to shade to the left. How could you check your work? Plug in negative 6 to the original. Plug in negative 7 to the original. Does it make it less than or equal to negative 72? It will, it does, so you're good. Only after you've done that do we do our final phase, which is interval notation. The leftmost value is negative infinity. We colored that arrow to the left. Our rightmost value is negative 5. We need a bracket on there at the negative 5 because of the fact we can land on there. It was colored in. So your negative infinity gets a parenthesis. Your negative 5 gets a bracket. We have to go from least to greatest. So our v is going to be from negative infinity to negative 5. Negative 5 gets included because we get that bracket.
Wait, why don't we flip this one around, the signs around?
We only flip it for 2 reasons. If we divide by a negative number or multiply by a negative number, so any kind of multiplication or division by a negative, or if we just need to turn it. And we didn't multiply or divide by a negative anywhere, so that didn't change it. And then the v was on the right side we wanted. It was on the left side, so then we're ready to go. Okay? So only turn an inequality if you have to turn the whole thing, or if you multiply or divide by a negative. Everybody good with 3? Okay, let's keep going. Number 5.
Go back up.
Oh, yeah. I'm sorry if I'm talking too fast. Just let me know. There you go. I always forget that you guys are not writing on like this, saying, because my students in the past, they could just write just like I was, you know. So you guys have more to write. So if I'm going too fast, always just let me know. We good? Okay. Now let's go to 5. In 5, we have 2 distributions. We have that, okay? So we're going to get 40 is greater than or equal to 56 plus 56n. That's our 7 distributing. Distribute the 8 to get 8n minus 16. So all I've done is distribute. Now we've got this list where we have some like terms. So our n's can be combined. 56 plus 8 is 64n. And then we have some just numerical pieces. 56 minus 16 is 40. And now that both sides are simplified as much as possible, now start moving things around. So let's subtract 40 from both sides. We get 0 is greater than or equal to 64n. Now we're dividing the 64 off. Sometimes my students in the past have thought that it doesn't work. If the 64 is in the bottom and the 0 is in the top, that's totally okay. You just get an answer of 0. 0 is a legitimate number, so it is your answer. Now this is one we do have to turn.
Because the 0 is on the left side.
Exactly, so let's turn that around, and we would get that n is less than or equal to 0. So now it's solved. It's in the correct sort of order and stuff. And so now we go to our graph paper. Do we want to open or closed at 0? Closed. And then are we shading left or right?
That way.
That
Right.
way. Left. Okay. And so you can put the little negative infinity. You can think about the fact there has to be a bracket on that, parenthesis on that. And then the graph itself, because the graph paper is in least to greatest order, and our interval needs to be in least to greatest order, they match up, they should be perfect. And so we get that n goes from negative infinity up to 0, includes it because I have a bracket. Is this starting to click a little more? Okay, that's why we're doing this. Let's review a little bit more and get these into your head. Okay, there's number 5. Let's do 7. I noticed the left side of 7. Good to go. Nothing's wrong. The right side of 7, there are some definite things we can put together. The -6 and the -7 are like terms. The n and the -2n. So let's mush those things. So we get that that's greater than -n minus 13. Now, you don't have to put the n first. You could have put the 13 first. It doesn't work. Just make sure you have the right signs on them and you're good. Okay. Now we need to start moving things around. It doesn't matter, but one person, if you move the ends to where they're going to be positive, are going to have to turn it. Another person might have to divide, so they have to turn it, but it doesn't matter. So let's say we add n so that our ends are on the left, because we need them on the left. That means this 1 needs to get scooched over. Okay, so we get -2n is greater than -14. So I've decided to go to the left because for equations, I always try to tend toward the positive. But for inequalities, if I can move it to the left, I move it. Okay. But I'm going to have to divide by a negative. So I got to make sure that I somehow mark on the paper some kind of reminder to myself. So I circle it if I'm doing it on paper. If I am doing it on an iPad, I sometimes will highlight it. But I got to remind myself, hey, next time I do this, flip that symbol. So we get n is less than +7. Now our n got to the right side. It's no longer negative. We have the correct symbol. So now we go up to the page. On 7, will we have an open or a closed circle? On 7, open, right? Because we don't have any equal to. Will we shade to the left or to the right? Left. So that's going to negative infinity, which gets you the parenthesis. On this particular one, 7 is going to get a parenthesis too, right? Because it doesn't include the 7. And so our answer for the interval is negative infinity up to 7. Neither thing uses a bracket because we can't get to infinity, negative infinity. We can't get on the 7 because we'd fall through the hole. Okay? Are we doing okay so far? Nice. It's starting to click. Okay, let's keep going. Number 9. Left side's good. Can't do a darn thing with it. Let's write it down. On the right side, the 7, we need to move that through. So if we distribute, we get 7 minus 28r. Now it's a matter of just moving stuff around. So let's add 28r to both sides so that our r's will be on the left, and they're going to be positive so that we kind of accomplish 2 things at once. And then let's subtract 40 to move it to the other side. Again, there's so many ways to do these. I'm just showing you the way that kind of occurs to me. So we get 33r is greater than or equal to negative 33, which comes out really nice. That kind of gives me a little idea. Oh, they were making these come out to be nice numbers, so I'm good. That's great. Divide off the 33 for an answer that r is greater than negative 1. Greater than or equal to negative 1. So do we want a closed or an open circle at negative 1? Closed or an open circle at negative 1. Yep, it's closed this time. We can stand there, so make sure to put a bracket on our interval. And greater than, we haven't had a lot of greater thans. A lot of this paper has been less than, but we're going to shade to the right, which goes to positive infinity. So now we're ready to set up our interval. Our variable was r. It's going to go from the lowest is negative 1, which is included in a bracket. Our highest is infinity going to the right. It always goes in least to greatest order for an interval. Good for number 9. Let's take a look at 11. 11 is one where we have both information on the left and information on the right that needs to be simplified before we start moving things around. Okay. So let's look at our left side for just a minute. For our left side, if we distribute in the -5, you get -15 plus 10b. Make sure that you use that negative in both distributions. On the right side, if we distribute the 4, we get 4b minus 28. On the left side, we still have nothing left to do, or we don't have anything else to do, so leave it. On the right side, we can combine those just plain old constants that are there. So we get, that is a b, by the way, we get 4b. My 6's end up looking like, or my b's end up looking like 6's, and my s's and 5's look the same, so I'm sorry, but that's 4b minus 33. And now you can start moving things around. So getting that b to the left is a good strategy for inequalities, so why not subtract 4b? Which means let's add this 15 so that we've got things to the left, things to the right. So then we have 6b's left on the left, and then 33 minus 15 is -18 on the right. And it's great, 6 does go into 18 nicely. So when we divide by 6, we get that b is less than or equal to -3. So we did get a really nice number when it was all said and done. And then we should be starting to get the hint of things, how this works, but I think let's just remind you, we're going to put a closed-in dot at -3, less than shades to the right, that's going to -infinity. This has to have a bracket. So then always set up your interval from the left side of your graph paper to the right, left to right, least to greatest. So our interval says that b would go from -infinity up to -3. Include that in a bracket because it was a closed-in or equality. How's 11 look? We good with number 11? Okay, I'll let you catch up on that. Make sure we're in the same spot. And remember, I post these videos so then you can review at any time and get yourself always caught up, or if you just want to review something. Okay. Now, the last ones on the page are compound inequalities. We haven't talked about them a lot, okay? So I really only want you to do on your own 14 and 22. Okay, so you can skip 16, 18, and 20. Okay, so you're only going to do 16 and 22. I am going to do with you 15. Yeah, I'm going to do with you 15. And I'm going to do with you, since it's right under it, 17. So on the last page, you're only responsible, because we'll do 15 and 17 together, you're only responsible for 14 and 22. Okay?
So we're going to do the odd ones.
So we're going to do the 15 and 17 right now. You're going to do 14 and 22 on your own. Okay, so let's do 15. 15 and 14 look alike. So you can use 15 as a resource when you're going to do 14. Okay, so let's do 15 by or together. Okay, so remember 15 and 14 look alike. When you have two inequalities with an or between them, it's one of the nicest type because you were just going to solve each one independently, And then we're going to throw it onto the graph paper. We color in what we color in, and that's going to give us the interval. So our first piece here, I would probably subtract 8 from both sides. Get that 4k is greater than negative 16. Divide off the 4, so k is greater than negative 4. Go to your graph paper, put your open circle at negative 4, and shade to the right. Okay, so whatever you get, you just put on the graph paper. You don't have to think much when it's an or, when it is a union of two separate inequalities. You just solve them. Same thing for our second piece. We're just going to solve it. Let's subtract 6 from both sides. We get that 8k is less than or equal to negative 72. And then when you divide by 8, you get k is less than or equal to negative 9. So then you just plop that onto the page. Now that one has a closed-in dot at negative 9, and we shade to the left. So our answer is going to use both negative infinity, and it's also going to use positive infinity. Okay? So when you write the answer, you do it exactly like you did the before, except we're going to have two intervals. We have to include this interval. Now think about if you just had that as our answer from like the last section of things. We would just write that from negative infinity up to negative 9, include it in a bracket. Now how do you do it differently for the notation if you have a separate piece? All you do is put a little u between them. That is just a fancy way of saying the word or that was written up on the page before. It is this piece, or it could come from this piece. We don't care. That's what that means. That's a union symbol. And now, least to greatest, we have to include the red piece. So we're going to go from negative 4 to infinity. We're going to have a parenthesis on the negative 4. Sorry, that doesn't look like a very nice parenthesis. We're going to have a parenthesis on the negative 4 because we don't include it. And so this follows the number line. I was at negative infinity. I had to stop at negative 9. I could include it with a closed-in dot. Then I went right to the right of negative 4. I could keep going to infinity. So it should follow the number line. Whether you have 2 pieces, 7 pieces, 20 pieces, it should follow the number line perfectly. You skip it in the interval. 15 makes sense? Are we good with 15? Okay. 17 is actually a, instead of a union, it is an intersection. It is an and. But what's great about 17 is they've set it up for you. So something is, I call it between. We want our n between two numbers. It's stuck between two things, okay? Okay. So let's take a look at how we would proceed. I think of it as a 3D problem. Whatever I do, instead of an equation where I have 2 sides, it's just an equation that's 3D. It has 3 sides, 3 pieces. So if you subtract one in the middle, because we want that n to be between 2 things, we subtract 1 everywhere else. And so we get negative 84 is less than or equal to negative 12, which is less than negative 12. And then we have to divide by a negative. When we do an inequality, even these funky ones, and we divide by a negative, we are going to turn the symbol. So, and then I'll show you how to deal with that in a minute. So we get 84 divided by 12, I think is 6, but let's just check. Oh, 7, I'm sorry. So that 7 is less than or equal to n. Oh, I'm sorry, we gotta turn it, Mrs. Hall. Is greater than or equal to n, which is greater than 1. Is that number line order? Is what we got in number line order. Yeah. I'm sorry, no. It's not in number line order. Does it make sense mathematically that a number can be less than 7 but more than 1? Yeah, it makes sense, but we want it to follow number line order. So think of if we, no, I can't draw, but think about if we put this somehow on a little pole and we could actually rotate it around. The symbols turn, the numbers turn. So you need to write this in least to greatest order. So it's going to be 1 is less than n, which is less than or equal to 7. That's the correct answer. The other one is not in correct notation. The between ones, it has to follow the number line. So we swivel it so that it's in number line order. The betweenness should always end up using the less than symbol because our number line is least to greatest order. Okay, so that's our final answer. Let's put it on the page. We have an open circle at 1. We have a closed circle at 7. We color in everything between those things. So I always think of when it's this 3D kind of problem as between. I always think between. The interval is great. It's just right there on the page. I had an open circle at 1. I stop at 7. I can include it. So they are the most complicated to solve, but they are the nicest interval because it's just a starting and stopping place. It's a bounded interval. We know where it starts. We know where it stops. We don't have any infinities in these ones. Are you good with that? Okay. So you're responsible for doing the evens on the top page and just 2 odds on the bottom. Number 2 evens on the bottom, 14 and 22, okay? And then you'll take a picture of this. I would like it by the time I see you at the beginning of class tomorrow to be in Google Classroom, okay? That's what I would prefer. I prefer if you can get it in tonight because then you'll have practice. Tomorrow we'll review for the quiz. We do have a quiz over this stuff and all the stuff we've done this week. So simplification, equations, and interval notation. The quiz will be on Friday.